All right, so this next section is 3.4, and this is called the chain rule. Now, so far we've learned about the power rule, right? And then we have the product rule and the quotient rule, and these are all just different rules for dealing with derivatives, right? Or how to derive different types of functions. The chain rule is just another one. Basically, what this is what if we have one function trapped inside of another? How do we derive those? Okay, so an example which we will look at, or these are typical cases where you would use the chain rule. Like if I had f of x equals sine of 5x squared plus 9x, for example. That's an example of us having to use the chain rule. Why? Because we have an algebraic expression trapped inside of a trig expression. This does not mean multiplication, right? This does not equal sine of x times 5x squared plus 9x. That's not true. This 5x squared plus 9x is embedded in the sign, right? We are taking the sign of this expression. So again, this does not mean this times this. A lot of people do that right there. This is again an example of where we would use the chain rule, and we'll work this out in a little bit. Another example is you could have an algebraic expression trapped inside of another algebraic expression. Say, for example, we had 3x squared plus 5x minus 4 to the 8th power, and you were asked to find the derivative, right? Well, one way we could do it is with the power rule, right? In theory, we could FOIL this out, right? We could FOIL this out, but look how long that would take. This is the 8th power. You'd have to write this out 8 times and multiply it out 8 individual times, and you get this extremely large polynomial. It would take you an hour to do it, right? This is not saying, oh, 3x squared to the 8th, 5x to the 8th, 4 to the 8th, and you've expanded it. No, you have to FOIL this thing. This is another case where the chain rule will be beneficial or way easier to use. So again, it's just basically another derivative tool to derive some kind of function trapped inside of another function. I remember, like I talked about it last class, you can have, an algebraic expression inside of a trig function, or an algebraic expression inside of another algebraic expression. You can have a trig function trapped inside of another trig function. The possibilities are endless. So how do we do that, right? Like, let's try to figure out how to derive these right here. Well, the way the chain rule works is there's kind of like a formula, and it doesn't matter how many functions are trapped inside of another. Let's say we have uh, f of, I'm going to put g of x like that. So we have this right here, and we're trying to derive it. So I'm going to use different colors because it makes it a little easier to see. So we have two functions, right? We have some f and some g. And again, they could be anything. This could be algebra and algebra, or algebra and trig. Now, we're taking the derivative, right? That means prime. So what we're going to do is, if we were to actually work this out, this is equal to f prime of g of x times g prime of x. So what happened right here? Basically what we did is, with the chain rule, we derived the outside piece first. You notice right here, I just took the derivative of f, but I still kept the purple stuff as it was. I didn't do anything to it. I still kept it inside. So you derive the outside function first, you leave everything else alone. Then once you're done with that, you move to the next inner piece. Then I had to derive the inside portion. See that right there? So basically, with the chain rule, you start from the outside and you derive one piece at a time, moving towards the center. But as you're doing that, though, you leave everything else alone. So again, I didn't say, oh, it's f prime g prime of x. I had f prime of the inside. I didn't touch the inside yet. Then I went to the next innermost piece and derived that, and you keep going like that. So how will we try that out? Let's try it out with these two problems that I wrote right here. Let's come back to this. I'm just going to rewrite it with the different colors so that way we can see, you know, it's a little easier to visualize. If you want, while you're working these out at home, you can use like a pencil, different colored pens, right, to simulate the different functions. So here we go. We have, you could say that the sine of x is your f right here. The purple stuff is your g, right? We have an algebraic part trapped inside of a trig part right here. Now, if we were to derive that, f prime of x, if we were to derive this, or the way it works is you derive the outside chunk first. What is the outside chunk? It's the sine of x right here. So if we take the derivative of sine, remember the derivative of sine is cosine. Now, you only derive one little chunk at a time, so everything else stays the same. This is still 5x squared plus 9x. Remember, that's what this formula calls for. Look what we did down here. What did it say? Oh, we only derived the outside first. We left everything else alone. We didn't do anything with it, so I just basically kept that 5x squared plus 9. But now, if we continue with the chain rule, it says times g prime of x. Well, what was g of x in this instance? It's the stuff trapped inside the sine. So now we need to derive 5x squared plus 9x. And when you do that, well, that's just the power rule, right? Derivative of 5x squared is 10x for the first. Derivative of 9x is just 9. And that's it. You stop. That's your final answer. Don't continue. Don't sit there and keep deriving this and go on and on. No, you derive one chunk only. All right, and you only do it once, meaning I derived the cosine first, left everything else alone. Then I moved to the next inner piece, which was this, and I derived that one. So that is your final answer. It's all this right here, multiplied all out together. That's as far as you can take it right there. Now, what about this next one? So again, I'm going to rewrite it with the different colors. We have f of x equals 3x squared plus 5x minus 4, and all that's raised to the 8th power right here. Now with this one, we have an algebra trapped inside of an algebra or an algebraic expression. You have all this purple stuff trapped inside something raised to the 8th power. But again, how are we going to derive that in this case? Well, you have to derive first the outside component. What is the outside component? Is it the purple stuff or the black stuff? Well, it's the black stuff, right? That's the outside stuff right there. So first we need to take the derivative of the outside portion. Well, that's just the power rule, right? If I cover this up, you basically have a chunk of stuff raised to the 8th power. Well, how do you derive exponents like that? It's just with the power rule, right? So I have to say, oh, this is 8. And then the inside doesn't change. We're not deriving that yet. So we drop all that down. But remember, we're taking the derivative of the outside component. That becomes 7, right? Why? Because it's the power rule. Like if we had to derive 8x or x to the 8th, for example, this right here, like if we had y equals x to the 8th, how would you derive that? You'd say, oh, that's just 8x to the 7th, right? Same thing that we did right here. It's just instead of it being a little x term, it's all this junk trapped inside. So same thing. Now remember with the chain rule, we still have to continue to derive, right? So far we derived, the black stuff, right? The written in the black marker. We did the outside piece. But now we have to go ahead and do the purple stuff, right? We have to derive the purple stuff for the inside piece. And whenever you go to the next chunk that you derive, it's always connected by multiplication. Now if we derive the inside, well, derivative of 3x squared is 6x. Derivative of 5x is positive 5. And remember, derivative of a constant is just 0. So this is your derivative right here. So again, it's just one chunk at a time. You start from the outside, and you derive the outermost chunk. You leave everything else alone. Then you go one step further inside. You derive that chunk. You leave everything else alone, and you keep going like that. So let's go ahead and do a few more. All right, what if we had something like this? F of x equals the square root of, now we have 6x cubed plus 2x squared minus 8x. So we want to derive this. This will involve the chain rule. Why? Because you have two expressions. You have one algebraic expression trapped inside of another, right? Because this root, what is that? That's really all this stuff raised to the 1/2 power. If you recall, I said, oh, whenever we derive, or later on we'll take antiderivatives of expressions involving radicals, you should write them out in exponential form. Now the square root of whatever can be written as whatever to the 1/2 power, right? Because remember, this index here is 2, unless they state otherwise, whether it's the third root, fourth root, or fifth root. All right, so let's see. So f prime of x. How are we going to do that? You have to do the outside chunk first. Now the outside chunk is the stuff to the 1/2, right? It's the 1/2 part. That's the outside stuff. So how do we do that? Well, that's just the power rule. So we take that 1/2, move it out in the front. Remember, when you do the chain rule, when you derive one part, the inner stuff does not change. So this is still 6x cubed plus 2x squared minus 8x. But now what happens up here? Remember, we did the power rule, right? Remember, the power rule says take that exponent, throw it out in the front, but then you go 1/2 minus 1, right? So we get negative 1/2, right? That's just us doing the power rule. 1/2 minus 1. Remember, you got to subtract that 1 from the exponent. That's where this negative 1/2 is coming from. The power rule, 1/2, you slap it out in front. Where did this negative 1/2 come from? Because the power rule says you always subtract 1 from that exponent, correct? Like that. Now I'm going to erase this right here. Now we're still not finished with the chain rule because we've only derived the outside chunk, right? Now we have to derive the green chunk, the stuff on the inside. And how do we do that? Well, we're going to connect it by multiplication. Derivative of 6x cubed is 18x squared. Derivative of 2x squared is 4x. Derivative of negative 8 is negative 8. And then with this one, we can clean it up a little bit. Why? Because why this 1/2, right? I can take this 1/2 And we can't multiply it into this expression because it's raised to the negative 1/2 power. But we can take it and multiply it into this right here, right? Because it's to the first. If you notice, whenever we do the chain rule, when we multiply the inner stuff, we're not keeping this exponent that it was initially associated with, okay? You're not going to keep carrying these exponents over and over and over like that. So if we take this 1/2 and multiply it into this right here, we have, let's make a note like this and all this stuff. A half times all this is just basically 9x squared plus 2x minus 4, right? That's what we're left with. And then I'm going to drop this component down. But again, we can't multiply this 1/2 first one. Why? Because it's raised to some weird power, or it's just raised to some exponent other than 1. If it has an exponent other than 1, you have to actually break this apart first before you can multiply that constant through, or whatever it is. So this one was just the first, so that's why we could just go out there and basically distribute the 1/2. All right, now what if we had, say, let's try another trig function like f of x equals cosine of 2x cubed. There we go. Let's say we want to find the derivative. So chain rule again, right? Why? Because we have an algebraic trapped inside of a trig function. What do we need to do first? Derive the outside, correct? So we got to take the derivative of cosine first. What is the derivative of cosine? Remember, this is a tricky one because it's negative sine. A lot of people forget the negative part. So we have negative sine of, and nothing else changes, so this is still 2x cubed. And then now that we've derived the outside chunk, we need to derive the inside chunk. So the derivative of the purple stuff is 6x squared. And then we can throw this out in the front, right? Like 6x squared times the negative is just negative 6x squared sine of 2x cubed. That would be your derivative in that case. And then let's make them a little harder. Right, let's up the difficulty. Like what if we had, I'll say y equals 1 over x to the fourth plus 2x cubed minus 6x squared to the fifth power. This looks ridiculous, right? Because now you have a fraction and we're trying to find the derivative, right? Take the derivative of this thing. So you may be thinking, oh, we have to do quotient rule right here. Yeah, you could do quotient rule, or what we could do is we could kind of manipulate it algebraically a little bit. I could say this is, you know, x to the fourth plus 2x cubed minus 6x squared to the negative fifth power, and I could say 1 times that. So this 1 is this. Remember, negative exponents, if we make them positive, we'd have to flip it, right? So if I flip this expression here, we get back to here. So that's technically legal. That is a trick that you can do if you want to avoid the quotient rule, is you can just rewrite whatever's in the bottom up top by making the exponent negative, and then you would have some kind of product rule, right? Like if this was x instead right here, we'd have to do the product rule. But in this case, we don't have to do the product rule. It's not necessary because that's a constant. So what are we going to do right here? We can chain rule this, right? Because we have an algebraic function trapped inside of another algebraic function. I'm just going to rewrite it using different colors again. So we have y equals, and I won't put the 1 because 1 times whatever is whatever, but if this was like 3, correct, I will put the 3 out in the front times everything else. So we're going to have this. And this is just our original function. We just rewrote it. Now, chain rule says you derive the outside chunk first. What is the outside chunk? It's the blue stuff or the black stuff? It's the black stuff, right? Because you can see, oh, this x to the fourth stuff is trapped inside that thing raised to negative fifth power. Now, again, the chain rule says you derive the outside first. So this is the outside component. All this stuff raised to negative fifth. What do we do right there? That's the power rule. So we drag out that negative 5. The inside does not change, right? We still have x to the fourth plus 2x cubed minus 6x squared. Power rule says you subtract 1. Be very careful. This is a negative exponent, right? A lot of people will say, oh, that's negative 4. But no, it's negative 5 minus 1. So we get negative 6, right? Remember that you subtract 1. So negative 5 minus 1 is not negative 4, it's negative 6. Be careful with that again when you have negative exponents, all right? So we've derived the outside component, right? We did the outside, but now we need to derive the blue stuff or the inside stuff. Remember, whenever you go to the next little chunk or the next inner chunk that you derive, you connect it via multiplication. So now if we take the derivative of this algebraic stuff or the blue stuff, we get 4x cubed plus 6x squared minus 12x. And again, I don't put any powers or anything right here. You don't put negative 6 or negative 5 or anything like that. No, that only applied to the outside component. All right. So this would be your final answer. And sure, you can multiply the negative 5 in if you really wanted to, but it's not going to make it into this component right here, but it's not going to really make it any smaller or anything. And you cannot multiply this negative 5 into this because it's all raised to negative 6. All right, you actually have to FOIL that out before you can multiply the negative 5, but that's just creating more work. So you just leave your answer in this form right here. Now, what if we had, I will say, y equals tangent of one over x, something like that, right? Nasty looking thing. Again, chain rule. Why? Because you have a function trapped inside of another function. I have this 1 over x, an algebraic thing, trapped inside of a trig thing. So that calls for the chain rule. Now remember, ask yourself, what are we going to derive first? 1 over x or the tangent? Well, the tangent is the outside piece, so we derive that first. The derivative of tangent, if you recall, that is secant squared. Everything else stays the same though, right? We don't touch any of that stuff. Now we need to derive the blue stuff, right, for the inside. How do we derive 1 over x? Well, if we write that off to the side, like if we have y equals 1 over x, how do you derive that? Well, the easiest way is to go out there and write this as a negative exponent, right? This is x to the negative 1. Kind of like what we did right here, right? When we moved this expression up the numerator, we made the exponent negative. Same concept right here. It's just a lot smaller. Now, if we take the derivative of x to negative 1, how do you do that? Power rule, right? We're going to move this negative 1 out in front of the x. So we get negative 1 x to the what power? That's going to be negative 2. Remember that, right? Don't forget that you're subtracting 1 from this always whenever you do the power rule. So negative 1 minus 1 gets you negative 2. And we can say, oh, y prime, or the first derivative, is negative 1 over x squared. What did I do? How did I do that? Well, it's because the negative 1 stayed up top. How did this x to negative 2 go on the bottom? Well, because remember, if you have a negative exponent, you can make it positive, correct? So I just flipped that component down. Like with this, I could have flipped this down as well, right? Like I could have rewritten this as 1 over x to the fourth plus 2x cubed minus 6x squared to the positive 6th power. But it wasn't going to make it look any nicer or anything like that. So I did it for this one because it was just smaller. So remember, I just worked this off to the side. Why? Because we had to derive this blue chunk, right? We derived the outside first. The derivative of tangent was secant squared. You keep everything else the same. And then times the derivative of the blue stuff, which is negative 1 over x squared. And because this is just, a little nice single term, I'm just going to put that in the front and say, oh, this is negative 1 over x squared secant squared of 1 over x. And again, normally we put algebraic stuff. We put algebraic stuff first, and then the trig stuff next, like that. All right, let's check this out now. Let's see. Hold on. What do we have? F of x equals 3x squared, and then tangent. Well, I'll do secant of x to the fourth, just because something like that. And we want, f prime of x for the first derivative. Well, this one is even more complicated. It's not only the chain rule, it's the chain rule and the product rule right here. So it's nuts, right? You have to do all that stuff. Why do you need both? Well, because this is 3x squared times secant of x to the fourth. Two different things that we're multiplying, that's a product, right? Or if we were dividing, like we had secant of x to the fourth divided by 3x squared, you'd have to do the quotient rule, but you'd still have to chain. Now, which part needs the chain rule? Well, it's the secant of x to the fourth, right? Because chaining happens when you have something trapped inside of something else. Okay, so I'll just go ahead and rewrite it with different colors. So 3x squared is this guy, and we'll have secant of x to the fourth. Madness, right? So remember, with the product rule, it's when you have two things. Like I'll call this f and this g right here, right? So remember, product rule, I'll put PR was just fg prime plus gf prime. So as we're working this out, this is going to get super long, right? Because it's just a lot of stuff that we're deriving. But let's just A for time, right? So f prime of x. So we have to do the product rule first, right? So it says f times g prime. Well, f is just 3x squared. Well, that was easy. Now we take the derivative of g. G is the component that's going to involve us having to chain, right? Why? Because we have a function trapped inside of another, an algebraic trapped inside of a trig. How do we do that? Remember, just cover up the 3x squared. We're not worried about that right now. We're just worried about deriving g, right, from the product rule. So the derivative of secant of x to the fourth, how do you do that with the chain rule? You derive the outside first. So if we derive the outside, well, what's the derivative of secant? It's secant tangent, right? Or secant x tan x. But our secant, it's not just going to be secant x tan x, it's going to be secant of x to the fourth, and then tangent of x to the fourth. So remember, derivative of tangent, if I have y equals secant of x, y prime is equal to, if we have y equals secant of x, the derivative of that is secant x tan x. So remember, whatever your x is right here, initially, you had to put it in both places right there. That's why I put x and 4 here and here, because our x in that case was the x to the fourth instead of just plain old x. Now we're still not finished because we haven't changed it 100% yet. Remember, we only derived the blue for the outside first. Remember, derivative secant is secant tangent. So now that we've derived the outside, we need to derive the inside. So that's the derivative of the purple. What's the derivative of the purple stuff for x to the fourth? That is 4x cubed. So that was all this mess was g prime, right? That was just the derivative of this component right here. That was just this little piece. Again, we got to do the derivative of the outside first. So the derivative of secant is secant x tan x, but it wasn't just plain old x, right? We had x to the fourth. That's why I put these x to the fourths here. If it was secant of whatever, and we asked, what's the derivative of secant of whatever? It would be, or what's the derivative of secant of whatever? It'd be secant of whatever, tangent of whatever, times the derivative of whatever, like that. So now we need to go on to the gf prime, right? So all this is just f times g prime. So what is g in this case? G is this component. Thankfully, it's pretty straightforward, right? It's just basically, we just copy this function down. We don't need to derive it, so super easy. No work for that one. So that's g, correct? And then it says the rest of the product rule says f prime, or the derivative of 3x squared. Well, that is just 6x to the first, right? So that's your entire derivative, or first derivative, for the product of these two functions. And now, as far as rewriting it, we definitely should, because you notice we have x's here, x stuff right there. We can multiply those together. Normally you want the algebraic expression first and then the trig stuff. So 3x squared times 4x cubed is 12x to the fifth. We still have secant of x to the fourth, tangent of x to the fourth is all multiplied, and then plus the 6x, and then secant of x to the fourth. So yeah, you're always gonna have to be on the lookout for, oh well, it won't always just be, it's just a chain rule problem. It could be a quotient with a chain, or a product with a chain, like we saw right here. So these things can massively blow up. It just depends on what is going on. All right, let's try another. Why not? Let's say we have I want, what do I do here? Let's try y equals, say, 2x to the fourth, and then cosine of 1 over x cubed, like that. And we want to find, of course, y prime, or the first derivative. That's the question mark right there. So, same thing, right? We're multiplying two different things. 2x to the fourth times cosine of 1 over x cubed. That times indicates product rule. We have an algebraic expression trapped inside of a trig. That means chain rule right there. So it's going to look very similar to this one right here. I'll rewrite it with different colors again. Any of you guys have different colored pens or pencils, use a pencil, a red pen, a blue pen, purple pens, whatever. Write all your different little pieces in different colors because it kind of helps, right, to see, oh, which chunk you need to derive. So this, and cosine. There we go, right? 2x to the fourth, and then cosine of 1 over x cubed. So again, we have to do the product rule, right? Product rule, and then power rule. If you want, you can label, again, this is your F, and all this stuff right here is the G. That's all the G components. The product rule, right? PR, that's F G prime plus G F prime. Let's start this out. So y prime right here, well, f times g prime. F is easy, right? That's just 2x to the fourth. Now for g prime, that's what involves the chain rule, right? Because you have a function trapped inside of another function. Now remember, you got to derive the outside chunk first. So if you take the derivative of the outside chunk, that's the cosine. What's the derivative of cosine? That is negative sine. If you recall, though, with the chain rule, everything else stays the same on the inside. So this is still 1 over x cubed. Now we need to derive, got to derive the purple stuff, right? So how do we do that, right? How do we derive the purple stuff? Well, let's go off to the side, right? Let's say we had y equals 1 over x cubed. How do we derive that? We could do quotient, but it's easier to rewrite it as a product rule if possible. Or in this case, we can just flip that exponent, right? This is just 1 times x to the negative third power. So now we just have to do the power rule. Remember, the power rule says you take that, you bring it out front. Negative 3 times 1 is negative 3. And we get x to the negative fourth power. Remember, negative 3 minus 1 is negative 4 from the power rule. And this becomes negative 3 over x to the fourth. I did not flip this negative 3 down. Why? Because it does not have a negative exponent. Only things that have negative exponents applied to them get flipped. It's just the x that has the negative exponent being applied to it. So this is y prime right here. So I'm just going to put that, just drag that answer right here. Remember, this is only f times g prime. Now we need to go on to g times f prime. Remember, g was just this, right? We're just dropping it down. But now we need to derive f, right? Got to take the derivative of f. Remember, f was 2x to the fourth. That's really easy, right? Thankfully, it's just going to be 8x cubed. Nothing special is happening right there. So we've taken the derivative. Now let's go ahead and rewrite that, right? Like we can multiply some things like negative 3x to the fourth times 2x to the fourth, for example. What's happening right there? Well, let's look at it, right? Let's be careful. 2 times negative 3 is negative 6. Now check this out. I'll work it off to the side. This piece right here. Put it in green. You have 2x to the fourth times a negative 3x to the fourth. Well, let's look at this. 2 times negative 3 is negative 6. So look, you have an x to the fourth up top and an x to the fourth on the bottom. What can you do with those? Knock them out, right? Because x to the fourth divided by x to the fourth reduces to 1. So 1 times negative 6 is just negative 6. We still have this negative sign, right? From here. So a negative times a negative gives us a positive. So I no longer need that negative in front. So again, negative times negative gave us a positive, right? That's why there's no longer a negative in front right here. We still have the sign, though, of 1 over x cubed. And then plus the remainder of this, right? The 8x cubed cosine of 1 over x cubed. Don't multiply. I know some people are saying, why didn't he go x cubed over x cubed is 1, like how he did x to the fourth over x to the fourth was 1 right here. It's because look at where this x cubed is located. It's embedded inside of this trig function, right? You can't just magically pull this out and multiply this out. This is not inside with the trig function. They're existing in two different places. So this, all you can do is drag out in the front. Don't slash these out. You can't because this is not inside with this trig function right here. So that's your final answer right here. Now, what if we had, I'll say, f of x equals sine of, in a different color, 2x cubed. And we want f prime prime of x. So now we want the second derivative, right? More work right here. How do we find the second derivative? Well, remember, once you find the first derivative, you just take the derivative of the first derivative, and that'll get you to the second derivative. So f prime of x. Chain rule, right? Again, one thing trapped inside another. All right, so we have to derive the outside first. So derivative of sine, what is that? That's cosine. Positive, right? Everything else remains the same. It's still 2x cubed. Now we have to derive the inside piece, or the green. What's the derivative of the green stuff for 2x cubed? That is 6x squared. All right. So now this is basically 6x squared cosine of 2x cubed. Now, if you recall, this is only the first derivative. We want the second derivative. So now we need to derive this. How are we going to derive this? Well, we have to do the chain rule and product rule, right? It's actually very similar to this one, right? It's just that we have cosine of 2x cubed, right? Instead of 1 over something. So it's going to work out the same way how we just did this one right here. This is your f, and this is your g right here. So f double prime. All right, so I won't use different colors this time. If you want to, you can. Let's see what happens. So remember, product rule says f times g prime. F times g prime. So f is just 6x squared. Now we need to take the derivative of g. Remember, that's the chain rule, right? How does that work? You have to derive the outside chunk first, right? The outside chunk is just the cosine. But the derivative of cosine is negative sine. Everything else stays the same. The inside stuff stays the same. So this is still 2x cubed. Now we derive the cosine piece. We go and we derive the inside. So now we take the derivative of 2x cubed, which is 6x squared. In other words, it's all connected via multiplication. So that's f times g prime. Again, f was 6x squared. The derivative of g, or cosine of 2x cubed, that involves the chain rule. So we derived the outside component first. Derivative of cosine was negative sine. We left everything else inside alone. Then we multiplied times the derivative of the inside. The derivative of 2x cubed was 6x squared. Remember, that's just f times g prime. Now we need to go to g times f prime. So g, we just drop that down. So that's cosine of 2x cubed. Now we need to derive f, correct? So g times f prime. The derivative of f, or 6x squared, is 12x to the first power. And now let's, multiply stuff. We definitely can. Or combine a little bit. 6x squared times 6x squared times this negative, right? You get negative 36x to the fourth. And then sine of 2x cubed. And then with this one, we can move the algebraic component in front of the trig function. This is 12x. And then cosine of 2x cubed, like that. So there's still a few more types to do. I'm going to stop this for now, but pay attention to the next lecture that I'll upload as well. I'll call it, like, this will be like 3.0.